Hi everybody and welcome to today's LEGO Technic video. I'm really excited to present to you my latest piece of work. It is a gearing ratio calculator or simulator, and the motivation for this project was to do with some of my designs I've built in the past, and typically what I do, I will first create them in a tool like Studio.io. There's lots of other tools out there, but this is one of my favorites. And the problem I was trying to solve was the fact that even after I've designed my my model within Studio, it's quite often hard to visualize whether or not you got all the gearing correct. So in this particular example, this is one of my Pi Day designs, and the idea of this design was to create a gearing ratio of pi, or an approximation between the input on the right here and the output on the left. So the idea was to approximate, with this gearing device, two differentials, a gearing ratio of 3.1415. Now, of course, you can't create pi exactly, so at that time I created a fraction that was close to pi, and that fraction was 355 over 113. So I was trying to create a gearing ratio of 355 over 113 between input and output. And even though I designed this on paper and spent a lot of time designing it and thinking about it, even when I designed it and built it, it's still hard to tell whether or not that gearing ratio was correct. Sometimes you can make a very simple mistake in terms of the directions of the gears and things like that, especially with differentials, and I might have got it wrong. And even when I built it, it did seem to be pretty close to pi, or 3.14, but you can never tell exactly. So the motivation for this particular tool that I've designed is to validate and verify whether or not those gearing ratios that I've designed are in fact correct before I go to the effort of actually building the model. So that is what I'm going to be presenting to you today. Alright, so the first thing I have to do for my tool design is to choose what technology to use. So I decided to use just simply a web application that's just JavaScript, just to make it easier for everyone to be able to access it, rather than having to create, for example, a Windows executable or Mac OS or Linux. And part of that, of course, I had to create a website to be able to distribute that. So I've created a technicbrickpower.com website. The idea of that website is to pretty much host the tools, but I've also put some of my videos on there and some FAQ questions and things like that. So we'll just go to that website. Just need to go to your browser, type in technicbrickpower.com. That will bring up my new website. Here it is. Again, like I said, it mainly just contains some of my videos and things like that. But also I've created a tools section, and the idea is that maybe in future I'll create some other tools as well. But for now, I've got my gearing ratio calculator, so all you need to do is click on this window here, and that will load up the application. So as you can see, it just comes up with an intro like that, and the first thing you have to do is load your .ldr file. An LDR file is a Lego draw file, and most applications support that. So in Studio, the native format is a .io file that contains the model and other things like instructions and things like that. So the first thing you need to do is export your project as an LDraw file. So just do that there. We'll just export there like that. I'll just go back to my application for the gearing ratio calculation. I'll just open up that file, PyDayDiff. Open that up, and that will load it into the tool, and there it is. So this tool, you can kind of see the model like that. Now, of course, it's only loaded the relevant parts for the gearing calculation. It only really knows about gears, axles, and differentials, and other components that can actually be driven. So all the the lift arms and things like that are all not shown. The top right here shows you the frame rate. It's about 57 frames per second, so that's really nice. You can rotate the model like that and get a good view of it, zoom in and out, things like that. And so part of the idea is to be able to calculate the gearing ratios between the input and output. So on the left here, this is the input, and on the right there, that's the output. In fact, I'll just turn it around to match the way I had it in Studio. So this is my input. So what I can do, I've got various motors here, and you can connect a motor to one of those inputs and see the effects of that being animated. So I just connect, for example, this motor. What you do, you can select different motors, set their speed. The idea of the multiple motors is just so you can connect more than one motor if your model has got more than one kind of gearing path. So what you do, you click on the gear, and that will start flashing, and now that means you can now connect to any piece, and so I'll just drive this axle there, and look at that, it now simulates the entire gearing system. You can now easily see how quickly things are going. You can change the input speed, you can go backwards, go forwards, and then at the bottom left here it shows you some information about in particular gear that you're hovering over. So I can hover over some of the parts, and I'll just slow it down a little bit. So I can, for example, hover over the input. You can see at the bottom left that it's driven by motor 1. It's got a speed of 14 RPM, which is equal to the RPM I've set for the speed of the motor. And you can hover over any part and see those gearing ratios. So now what I really want to know is whether or not the output in fact is the gearing ratio that I'm after. So by clicking on that output, hovering on the output, if I can just click on it and highlight it and it'll just stay there, you can see that the ratio is correct. It's 355 over 113. So that shows you that I have in fact got the gearing ratios correct, but like I said, it's very easy to get it wrong. And the great thing about this tool, it allows you to validate the fact that your gearing ratios are correct and as expected. You can highlight particular parts, like you might be interested in that differential. You can click the wee pin and that will just pin it to the output display there. Yeah, you can zoom in and out. Now there are some parts that aren't being used. So for example, some of these axles were used for the support of the framing, so I can just hide them using this icon here. So that just shows you all the components that are moving. I can drive in other parts. So for example, I can drive it backwards. Now of course I'm now driving the output and looking at the inputs. Now I'm going to see the opposite ratio of minus 113 over 355. That's just the inverse. So yes, so this validates that the pi day differential does in fact work correctly. We can still see we've got a very good frame rate, 57 frames per second. And I'll now show you the next model. I can disconnect the motor just by clicking like that. Okay, I'll just show you one of the other projects that I've used this tool for. So that is my omnidirectional vehicle. I'll just go over to that. I'll just open that project within Studio. There it is, omnidirectional vehicle. So this particular project is a video I presented not long ago. The idea of this model is that you can drive forwards and backwards and rotate on the spot by rotating the wheels in a particular direction. Now probably the tricky part of this model is that some of these wheels had to rotate clockwise and the other ones anti-clockwise, and having a different gearing ratio between those wheel rotations, between 1 to 3. So you have to watch the video to understand that, but I'll just show you how this works. So again, we have to export this as an LDRAW file, just like that. We go back to our gearing calculator, and in this case we will go and load that up. Omnidirectional vehicle, LDR, there it is, it loads. Now it loads very quickly because some of the files have been cached in the browser. First time you do use the tool, it will load up a little bit more slowly. You can see this particular model is a lot more complex, got a lot more gears, and the frame rate is about 30 frames per second. And that of course will depend on your computer and your browser and things like that. So in this particular model I've got two motors, one to turn the wheels, or to drive the actual model itself that will rotate these bottom wheels. That is driven by this yellow axle up here, and the other motor drives the turning of the wheels, or the rotation, or to change directions. So first I'll just show you motor 1. So I click the gear there, connect that to the input, and that will calculate and start driving the model. So that allows me to see straight away that all the wheels are going in the correct directions. They're all going either clockwise together, or I can change directions and make them go forward like that. And at the same time I can also see the gearing ratio between the input motor and any one of the wheels. But so I click on that component, I can see that it's being driven by motor 1, and it's got a ratio of 3 to 25. Of course all of them will have that same ratio, 3 to 25, and like I said, you can see they're all going in the correct directions. So I can now also connect motor 2 to the rotation part. So the rotation axle was here. It's kind of been made translucent because it's not being used, but you can still see it. So I can connect motor 2 to that component, and that will start rotating those turntables. So we can now also see that the turntable components are rotating. Now of course the model or the simulator doesn't know anything about turntable connections on the other parts, so the actual wheels aren't rotating, but this just simply shows you again the gearing ratio between that input and those turntable components. So in this case here we've got a gearing ratio of 1 to 140, so it's very slow. We've got that worm gear in there slowing that down, but the main thing I want to make sure is that one, for example, is 3 times as fast. So you can see there that's 3 to 140, so that's triple the speed of the other one. Now of course with the worm gear simulation as well, you can only drive worm gears in one direction. So for example, if I try to drive this axle here, which is, or this gear, onto the worm gear, it will flash red like this because I've actually created I guess a gear jamming. You can't drive this gear and then drive a worm gear. Worm gear is only one directional, so that again shows you whether or not you've got any sort of gearing inconsistencies or jamming, because in this case you can't drive that worm gear backwards, so I can only drive it forwards. And again, by clicking the hide unused parts button, it just clarifies the whole model a little bit and just removes all those components that aren't being driven, that are used for framing, which of course the model doesn't know about until you start actually animating and driving the components. Okay, so that is the omnidirectional vehicle simulation. Again, frame rate's a little bit slower, but it's still sufficient to be able to see kind of what's going on. It's been very useful just to validate this particular model. And I'll now show you my third and final model as a demonstration. Just one moment. Alright, so the other model I wanted to show you was one of the designs I did a while ago of a Ferrari gearbox simulation. So I'll just go back to Studio, load that file. So I'll just open that particular model, Ferrari gearbox. Now the idea of this gearbox here is it's trying to create a manual version of a Ferrari automatic gearbox. It's got 8 different gears, 7 forward gears and 1 reverse gear. And the idea is that each of these manual gears, as closely as possible, simulated or approximated each of the automatic gearbox gearing ratios. So I had to create 8 different ratios, and again, it's always hard to get those exactly correct because it can get complicated when you're doing these designs, and you can get a bit lost in the number of gears that you end up with. So again, I'll just export this file into LDRAW format. We'll go back to the gearing simulator. I will just load up that Ferrari gearbox, and it's got 168 parts. They've all been loaded. Here is the model. Just kind of zoom in, and again, it's removed a lot of the components that it doesn't support. So in this case, it doesn't support some of the engine piston components and things like that. It doesn't support chains, but again, it supports the majority of the components that are required or sufficient to be able to simulate what we're after. So in this particular model, the input's down here. That's the axle that the motor drives, and here is the output. So what I'll do first is the output. I will just highlight or click on that, and then I'll pin it, so that way I won't lose track of it. I can easily see what that value is of the output relative to the input. Now this particular model has got the 4 different driving rings. Now I do support switching driving rings, so you can just select a driving ring. That will then, in the user interface, bring the switch button that allows me to switch the driving ring into different positions. So in this case, the first gear, the driving ring has to be, I think, at the bottom like that, because the first gear with the lever goes forward, so it actually drives the ring backwards, and that should create the first gear. So what I'll do, I'll connect the motor to the input. Actually, wrong one. Connect the motor to this input. That was in fact the output, and now it's simulating the whole gearing system. So we can see the output gear has got a gearing ratio of 3/10, or in this case -3/10, is going in the opposite direction to the input. And yeah, so that is correct. That is the correct first gear. If I want to go to the second gear, I have to switch that driving ring like that. I'll push switch, and then that will go back to neutral, and then it will go into second gear. So now we can see that the second gear output is 4/9 instead of 3/10. So that is the correct second gear. You'll have to watch the video to see all the gearing ratios that I created. But again, using the simulation tool, I can go through each of those gears and find out whether or not I got the design correct. It's actually interesting because I actually ended up discovering that I made a mistake, I think in the gear number 6. Instead of being the correct amount of 8/7, it actually turns out, so that's that one there, it turns out the gearing ratio I ended up having, instead of 8/7, I ended up with 7/8. So I actually got those gears backwards. So in that respect, the tool has been useful. It's only in hindsight. I actually built this tool after I created this particular gearbox, but it did tell me that I actually got the gearing for one of the gearing ratios backwards. So I guess at the time I was designing it, I had to drive it from the driving axles to the driving rings, but in fact at the time I got it backwards and went the other way, so that was a mistake I discovered in this particular design, that gear number 6 was incorrect. Now of course with these driving rings, if you connect 2 of them at the same time, you will create a conflict. So by doing that, for example, it'll show you that you can't drive the whole model with 2 driving rings activated at the same time, as that will create a gearing jam. So again, you've got to make sure that the driving rings are all connected the right way. By disconnecting that one, we go back to gear number 1. So again, that is that 3/10. If we go to the reverse gear, which is the last switch, which is over here, then in fact it should be in this direction. We can see that this is now a reverse gear rather than forward gear. Alright, so that summarizes my gearing ratio calculation or simulation tool. I found it very useful. Again, we can remove some of the unused components and get a really good view of what you've designed. Hope you enjoy this tool, get some use out of it. Please give me some feedback whether or not you do find it useful. Like I said, I found it useful, so please try it out. Yeah, please like and subscribe, and see you next time. Bye.